Hello everyone, welcome you all. Another session of chemical reactions and equation chapter. In previous class, I have discussed few questions with you related to this chapter, and today also I'll discuss very important questions with you. If you remember in previous class, I have discussed one question related to how to balance chemical equation. Now I'll continue with the same question, and in today's class I'll give you one more example of balancing chemical equations. Now just a second. Okay, so in previous class I discussed this chemical reaction with you, and in today's class we'll do this question. In this you have to balance this chemical equation. Question is given just in front of you. You need to balance this chemical equation, which is BaCl2, which is barium chloride. When barium chloride reacts with sulfuric acid, it results in the formation of barium sulfate and hydrochloric acid. Now let's see how to balance this. According to hit and trial method, look at the elements which are present in this equation. Here we have barium, chlorine, hydrogen, sulfur and oxygen. Okay, so I am writing here reactants and products and the name of the elements like this. First I'll write barium, then chlorine, then hydrogen, then sulfur and finally oxygen. Now just count the number of these elements on both the sides. First let's look at reactant side. Barium, here is 1, here is also 1, chlorine 2, here chlorine 2, hydrogen 2, hydrogen 2, then we are hydrogen is 1 here, it's not 2 here, and here chlorine is also 1. So barium 1, 1, chlorine 2, chlorine 1, and hydrogen 2, hydrogen 1, then sulfur 1, here is also 1, oxygen is 4, here is oxygen 4. Now look at the reactant and the product side. We can see chlorine and hydrogen, they are not balanced. Their number varies in reactant as well as on the product side. So how to balance it? Now we need to balance chlorine first. So I just write 2 here. If I am writing 2 here, so now here oxygen also balanced and chlorine also. So in this manner, this equation is completely balanced now. So this is a balanced chemical equation. Next is, a student took 2 to 3 grams of a substance X in a glass beaker and poured water over it slowly. He observed bubbles along with hissing noise. The beaker becomes quite hot. Identify X and what type of reaction is it? If you remember, I discussed this kind of reaction of this quicklime is converted into slate lime. So if a student took 2 to 3 grams of a substance, which is X, in a glass beaker and poured water over it, heat is evolved, and this kind of reaction is known as combination reaction. CaO plus H2O, it results in the formation of calcium hydroxide and hydrogen gases evolve. So when calcium oxide, which is quicklime, common name is quicklime and the chemical name is calcium oxide, and this is slate lime and chemical name is calcium hydroxide. So when we pour water into calcium oxide, it results in the formation of calcium hydroxide and hydrogen gases. Okay? Then After this, no, sorry, this hydrogen gas is not involved, heat is involved. Heat is involved. And due to the evolution of heat, it's an exothermic reaction. It's exothermic reaction, or we call it combination reaction, because two reactants combine together to form a single product. So that's why it's a combination reaction. And all combination reactions are exothermic reactions. So here heat is involved, no hydrogen gas is involved. Next is, what do you mean by precipitation reaction? Explain by giving example. Precipitation reaction is that kind of reaction in which a precipitate is formed, and that precipitate is insoluble. So it settles at the bottom. So that kind of reaction is known as precipitation reaction. And the example of such kind of reaction is when silver nitrate comes in contact with sodium chloride, it results in the formation of silver chloride and sodium nitrate. So this is an example of precipitate. This is a precipitate which is formed during this reaction. It's a 2-mark question, students. Next is, which of the following statement about the reaction below are incorrect? One reaction is given in front of you. In this reaction, if you look at this reaction, just look at it. It's lead. Pb is lead. Lead oxide when reacts with carbon, it results in the formation of lead and carbon dioxide gases involved. Now, just look at the reaction and options. Lead is getting reduced, carbon dioxide is getting oxidized, carbon is getting oxidized, or lead oxide is getting reduced. So these are the 4 options given according to, on the basis of this reaction. Now, as you can see, gain of oxygen is oxidation. In oxidation reaction, we always add oxygen, or loss of electrons, removal of hydrogen. So these are the conditions which take place during oxidation reaction. And here, if you can see, in this lead, we are removing oxygen and loss of oxygen. Okay, so statement A and B are correct, and thus option 1 is correct. Okay, because we are removing oxygen from lead and carbon dioxide. As you can see, we are adding carbon with oxygen. So this is oxidation, this is reduction. So we are adding oxygen, it's an oxidation reaction. If we are removing, so it's a reduction reaction. I hope that question is clear to you. Now let's move on to the next question. In the following reaction, which one is reduced and which one is oxidized? What do we call this type of reaction? This reaction between iron oxide and magnesium. So, magnesium combines with oxygen. It means it is an oxidation reaction. So, when we are adding oxygen, so that agent becomes a oxidizing agent. And here we are removing oxygen from iron. So it becomes a reducing agent. So this is the reduction reaction. And when both the reactions are taking place together, so we call it redox reaction. If you remember redox reaction, redox, it means, red means reduction and ox means oxidation. So when reduction and oxidation reaction takes place together, we call it redox reaction. So this is a redox reaction. Now, next question is, take about 5 ml of dilute HCl. HCl is hydrochloric acid in a test tube, and add a few pieces of fine zinc granules to it. Which gas is evolved? Just write, first I write the equation, zinc granules plus dilute hydrochloric acid and what type of reaction takes place? Look here, ZnCl plus H2. First I'll balance this. Okay. Now look at the reaction. Now it's completely balanced. When zinc reacts with dilute hydrochloric acid, it results in the formation of zinc chloride and hydrogen gases evolve. Now tell me why zinc displaces hydrogen from this HCl. Any idea? Yes, because this zinc is more reactive than hydrogen. And if you remember, I talked about reactivity series. The metals which are placed above hydrogen, they are more reactive than hydrogen. They can easily displace it. But the elements which are placed below hydrogen in a reactivity series, they are less reactive and they cannot displace hydrogen. Here, zinc is more reactive, so it can easily displace it. And what type of reaction is this? It's a displacement reaction. Yes, this type of reaction is a displacement one. Okay, now after this, apart from this, I have already discussed few reactions with you. This reaction was based on this reactivity series. Okay, as I told you, just look at this reaction. Here, if you look at this reactivity series, hydrogen, place of hydrogen, where it is placed, I'll just mark here so that it's easy for you to understand. Okay. This is hydrogen. Yes. We place hydrogen here, and these metals which are placed above hydrogen, they are more reactive than hydrogen, so they can easily displace it. While these metals which are placed below hydrogen, they are less reactive, they cannot displace hydrogen. And when this displacement takes place, it means when one takes up the place of the second one, so this type of reaction is known as displacement reaction. So I hope these questions are clear to everyone. Now I'll just discuss few more questions with you. Okay. Now what will happen if we keep food which contains oil and fat in an open atmosphere? What will happen? Any idea? See, if we keep any food item which contains oil and fat, and if we keep it in an open area, so it goes under a process, and that process is known as rancidity. Rancidity. This is known as rancidity. In this process, the oil and the fats which are present in a food, they comes in contact with the oxygen and the air, and it results in the foul odor of food. This process is known as rancidity. And how to overcome this rancidity? What are the methods to prevent it? By vacuum, by adding nitrogen gas, or by adding antioxidants. So these are the methods with the help of which we can prevent rancidity. Now I discuss one more important topic with you, that's corrosion. Corrosion. Corrosion is a process in which the metal are reduced when they come in contact with oxygen and water. So that process is known as corrosion. An example of corrosion is rusting. due to collision, rusting takes place in iron. So when we keep any iron object in an open atmosphere, it comes in contact with the oxygen and it forms a brown color layer over it, which is iron oxide. And this is a brown color layer which is formed on the iron, and this is known as rusting. And how to prevent rusting? What are the methods involved in the rusting? There are different methods to prevent rusting, and what are those methods? Let's discuss. First is by painting or greasing. We can apply paint or grease on any iron article so that it will not come in contact with the oxygen. This paint or grease acts like a barrier. So it does not allow the iron object to come in contact with the oxygen and air, and it prevents rusting. Another way to prevent it is galvanization. Galvanization is a method in which we coat a layer of zinc over iron, again to prevent that iron from rusting. So these are the methods which, with the help of which, we can prevent rusting very easily. Now, apart from this, I have discussed few important reactions with you in this chapter, and those reactions are combination reaction, second is decomposition reaction, okay, and the third one is displacement reaction, okay, and displacement reaction is single and double, okay, and decomposition is thermal decomposition, photo decomposition, okay, and electrolytic decomposition. This electrolytic decomposition, and fourth is oxidation reaction and reduction reaction. Then we have redox reaction. So these are extremely important reactions in this chapter. So I'll just recapitulate all these reactions one by one so that concept will be more clear to you, because questions I have already discussed with you. And if you have any doubt, please write down in the chat box so that I'll take your doubt and clear it. First is combination reaction. In combination reaction, the reactants are combined together to form a product. So that kind of reaction is known as combination reaction. For example, Mg, that's magnesium. Okay, when it comes in contact with oxygen, it forms 2MgO, which is magnesium oxide. So it's a combination reaction, right? Then we have decomposition reaction. Decompose, it means one breaks down into different form. Okay, so in decomposition reaction, one substance, it breaks down into different form. That this decomposition reaction is just opposite to that of combination reaction. Now, thermal decomposition. Thermal, it means temperature. We are talking about temperature here. So it means when we are providing heat to this reaction, it is known as thermal decomposition reaction. And when we use electricity, so this is known as electrolytic decomposition reaction. And photo means when it takes place in the presence of light. So it's known as decomposition reaction. Then we have displacement reaction, when only one displacement takes place. For example, one element displaces the other element. That's known as single displacement reaction. And in double displacement reaction, so when displacement takes place twice, so that kind of reaction is known as double displacement reaction. Then we have oxidation reaction. In oxidation, there are three conditions: addition of oxygen, okay, then we have loss of electrons, a removal of hydrogen. So these three conditions occur during oxidation reaction. If we are talking about reduction reaction, here addition of hydrogen, gain of electrons, and removal of oxygen. And redox reaction, when both oxidation and reduction takes place simultaneously, we call it redox reaction. As the name itself indicates, red means reduction and ox means oxidation. Apart from this, we have exothermic reaction, and then we have endothermic reaction. In exothermic, heat is evolved. An example of exothermic is respiration, because when we respire, we release heat. So this kind of reaction is exothermic reaction. And the reactions in which exit, exo means exit. So if heat is exit or evolved, so that kind of reaction is known as exothermic reaction. And combination reactions are generally known as exothermic. Endothermic, when heat is absorbed, that kind of reaction is known as endothermic reaction. So these are the different reactions which we have already discussed, and I covered all the reactions when I was discussing this chapter in detail. Apart from this, in this chapter, I discussed about reactants and products also. What are reactants? What are products? Look here. Okay, if I'm writing A plus B, so it results in the formation of C plus D. So here this A plus B are reactants and these are products. If you look at this reaction which is in front of you, these substances are known as reactants and they are known as products. And this one is balanced chemical equation. So this one is unbalanced and this one is balanced chemical equation. What's the difference between balanced and unbalanced? As you can see here, if you look at the elements, they are not balanced. It means they are not equal on the reactant side and on the product side. So that's why we call it unbalanced equation. But we always need to balance a chemical equation because balanced chemical equation obey law of conservation of mass. Law of conservation of mass. What is this law of conservation of mass? How will you define it? What does this law of conservation of mass states? It states that the amount of reactants is always equal to amount of products, or mass of reactant is always equal to mass of products. So it means they are always equal. Reactants and products, they are always equal. So if we look at this reaction, here all the elements are equal, they attain equilibrium, so that's why we call it a balanced chemical equation. And a balanced chemical equation always follow law of conservation of mass. It always obeys it. That's why we need to balance a chemical equation. Then apart from this, balanced and unbalanced one, reactant and products, when we are representing any chemical equation. What is chemical equation? How will you define it? Any idea how will you define a chemical equation? If question comes in exam, define chemical equation, or how will you define it? So what will be your answer? A chemical equation is one in which one or more substance reacts with each other to form a new product. So that kind of reaction is known as chemical reaction. And when we are representing any chemical equation or reaction, it gives us clear idea of all the substances present in that reaction. For example, I'm taking another example of this one. Okay. This is a balanced chemical equation. Okay. If you look at this equation, these are the elements which are represented by their symbols. Instead of writing their full name, we write them in their symbol form. And subscripts, it represents number of atoms, it represents number of molecules, and plus sign indicates that these two compounds join together or combine together or react together. So when they react with each other, it means they are combining with each other. So this plus sign indicates this addition. It means they both are reacting with each other. And this arrow sign represents that this reaction is pointing towards in this direction. It means this arrow shows the direction of the reaction, in which direction it proceeds. And these represent the products. Apart from this, if any heat is involved or we are using any heat, we represent by this symbol triangle. And we always mention if we are using any conditions while performing that reaction. And we always write conditions on the top of this. These are the conditions. The conditions can be temperature, pressure, catalyst. Here one word is there, catalyst. What does it mean? And what's the role of this catalyst in a chemical equation? See, this catalyst, it only helps to speed up the reaction. It will not increase the temperature or it will not result in the formation of any new product. Its main role is to increase the temperature. So that's why we use this. Okay, now this I have already discussed these questions. Fine. Okay. Now look at this example. AgNO3 plus NaCl, AgCl, NaNO3. So here also if you look at this example, it's very important reaction. As you can see here, when this reacts with this, it means it can easily replace it. Here silver chloride is formed and sodium nitrate is formed. So this is a balanced chemical equation. As you can see here, this is silver nitrate, sodium and chlorine. Okay. when these elements combine together, it results in the formation of new product. So this kind of reaction is a balanced one. So when we are representing any chemical equation, you can take any example of a balanced chemical equation. It always represents in which direction it proceeds, number of molecules and atoms. Chemical reaction shows that what kind of elements are present into it and under what conditions it performs. But it does not tell whether the reaction is fast or slow. So it will not give this kind of information. So these are the examples of a balanced chemical equation and what are the reactants and the products present in it. Then after this, one more important question is, on the basis of this redox reaction or oxidation and reduction, generally on this topic 1 mark question comes in exam. They'll give you one reaction and then they'll ask what is the reducing agent into it, what is oxidizing agent, or whether it is a reduced reaction or the oxidation reaction. You have to mention it. So first of all, look at the reaction carefully. In this reaction, if you look at this reaction, as I told you earlier also, here oxygen is attached with lead. And when we are looking at the product side, so this oxygen is nowhere now. This lead is alone. And means we are removing oxygen from lead. So we are removing oxygen. Remember, removal is the reduction. So here this lead is reduced. And this is also known as reducing agent. Or sometime in question they'll ask, name the reducing agent of this reaction. So you have to write the reducing agent is lead. You have to write like this, and reduction reaction takes place here. This is the reduction, and oxidation is this one, oxidation, because we are adding oxygen with carbon. So this, and here we talk about carbon, it is oxidizing agent. Okay, and oxidation takes place at this carbon place. So it's very frequently asked question. Now, and when these two reactions are taking place together, this is redox reaction. One more thing I would like to add in this, students, see, when any chemical reaction takes place, so it tells the state of the element in which they exist during the chemical reaction. As you can see here in brackets, it's showing S. It means it exists in solid state. And this carbon also exists in solid state. This S is solid and this is gaseous. So it means when chemical reaction takes place, it tells us the state of the elements which are involved in that chemical reaction. Okay? Now I think this chapter is clear to everyone and all the questions are very much clear. And please go through these questions and do practice a lot of these chemical equations and the reactions. More important is how you should know how to balance the chemical equation by using hit and trial method. So try to solve more and more questions. Okay, I'll take one more example here of this hit and trial method. We have this equation in front of us. again reactant and product. Now I'm writing elements. Iron is involved, oxygen is involved, and magnesium. See student, whenever I am doing any question, I always try to solve that hidden trial method also. I always try to explain hidden trial method which we are using for balancing any chemical equation. And the purpose of doing this balancing every time is so that it will be more clear to you. If we look at this reactant side, just count. Iron is 2, on product side iron is 2, and oxygen is 3 here, and here is oxygen 3. Look here, yes. Then magnesium is 3 and magnesium is 3. Now it is a complete balanced chemical equation. I hope it's very much clear to you. Now thank you everyone. I hope this chapter is clear to all of you. All your doubts are clear now, because I have taken ample of questions from this chapter. Let's look at the questions again which I have discussed in previous class. It is based on reactivity series. Again, what happens chemically when quicklime is added to water? So you need to write equation which is involved into it. Then by combustion reaction and oxidation reaction, just now I have explained, because when a combustion reaction takes place, it takes place always in the presence of oxygen. And oxidation reaction itself is a kind of reaction in which we add this oxygen. Okay, now it based on density. Okay, sorry, it based on this corrosion. Why we always pack food in an aluminium foil? Because aluminium foil does not corrode easily. That's why we use aluminium foil for packing food materials. Okay, and we are not using iron articles. And generally these type of questions can come in exam. So please go through these type of questions. Although I have explained, these are very important questions. And like if a student burn a metal which produces dazzling flame, white powder is produced. It's a 2-mark question, student. So you need to write the name of metal A and B and then write the equation. So these kind of questions can ask in exam n number of times. So please go through these questions. Thank you all of you. And have a nice day. Enjoy your day.